Hello, this is Answer Everywhere. Today, we're taking a look at Apache Mesos, which is a cluster management system similar, I guess, to Kubernetes. I think it was open source before Kubernetes was around, or maybe before Kubernetes was open sourced. And it helps you manage a whole cluster of machines. Imagine you run a data center, and it lets you manage them as a single pool of resource, kind of in the same way as Kubernetes. In fact, why don't we open up the Wikipedia article here and see when it's from. That's the stable release. So it began as a research project in the UC Berkeley RAD Lab, 2009. And Kubernetes, I think, is way later than that. Kubernetes. 2014. So I've never used Apache Mesos. My impression of it is a lot of the Apache projects from the kind of 2000s era are based around a lot of the similar ideas to what Google was doing internally at their data centers. And they're kind of like the open source version of things that were published in papers by Google. In this case, I think probably Mesos predates the Borg paper, which is where Google described what its in-house cluster system was. Large-scale cluster management at Google with Borg. Do we have a year here? 2015. So I don't think that Mesos is like a clone of Google's internal stuff, the way that something like Hadoop was essentially a clone of the MapReduce stuff. But it's kind of in the same vein. And my kind of personal bias is I think of Mesos as a little bit of the older generation and has been obsoleted. Although I guarantee there are still important uses of it. There are still large organizations that use Mesos. And there are probably also niches where it has solutions that Kubernetes doesn't have. Sarthak, hello. Someone doing real stuff as opposed to AI. Is that what you mean? Sarthak, are you the one who requested Mesos? Your name looks similar to the username of the requester. Okay, so we're going to dig in. I'm on this repo, but it looks like it's the newest commit is 8 months old. I don't know if there's a more recent branch. I think Wikipedia told us when the stable release was. 4 years ago. Is it discontinued? I don't believe that. Hmm. 2022. Is it discontinued? Is it abandoned where? Reaches end of life. The decision to move Apache Mesos to Attic has been reversed at the end of the era. End of the year. What? I don't know what Attic is. Is Attic like a fork? The Apache Attic. Okay, so maybe we should take a quick look at this. Let's ask DeepSeek, I guess, since we're here. Is Apache Mesos still actively developed? And let's also ask Gemini, because I'm not so sure about DeepSeek. It's not actively developed as it once was. It's seen a significant decline. Okay, so I'm guessing this is probably Kubernetes, Docker Swarm, deprecated in Nomad. And basically it's killed by Kubernetes, essentially. Hello! But I did get a request to look at it, so we're going to look at it. And the person who requested it donated to the channel. And that's how you get your requests scheduled. Okay, so let's dig in. It's mostly C++. which I don't know why I was expecting Java, but that's where we are, C++. A little bit of Java, a little bit of Python, probably just to either do testing or to integrate those languages somehow. Can I emoji this? Hi. I think I already said hi, but I'll say hi again. I also have it open in Emacs. I don't know which one I want to do. I guess I'll do GitHub for now. So site, I'm going to guess, is the website. Include is going to be the headers. And third party is going to be like vendor dependencies. Bin is probably not where we want to be. It's either for building or a bunch of shell scripts. I'm going to guess for building, maybe the release binary. And I'll keep include in its own window here because it's going to that'll make it a little bit easier to jump to the headers if I'm looking at the C files. But I guess I'll browse the C files because sometimes there's important functionality that doesn't show up in the headers. Okay, log, we can definitely ignore. JVM, it's going to be some sort of JVM integration, same with Java. I don't know if that's worth looking at. There's some examples. Maybe I'll look at some examples. Docker is going to be some sort of support for Docker. Deploy, I don't know if that's essential or not. I don't know what CSI will be. Authorizer should be some sort of authorization layer. Same with authentication. AppC might be important. CLI is going to be the command line client. Credentials could be, since we already have authn and authz, credentials might be for like managing secrets or credentials. Have you tried VS Code for browsing GitHub? I have. I occasionally do it on the channel, but I don't a lot. Does VS Code index? Well, I'll try it if I can't jump to a definition. I don't know if VS Code, the hosted VS Code automatically indexes things that GitHub doesn't already index. But I do have everything indexed on Emacs, so I can do that there if I need to. Sched should be the scheduler, although we also have scheduler. We also have secret, which is different from credentials. We have slave, which I'm going to guess is like what you might call a worker. Status update manager is presumably going to update statuses. So, I mean, we talked about this in Kubernetes. Zookeeper, give me a second. So, who knows what V1 is? I'll open V1. I'll open Watcher, and I guess Web UI just for fun. Zookeeper is probably a reference to Apache Zookeeper, which is a like a distributed lock service. It's kind of like Raft is the modern one, but it's kind of like the Raft algorithm as a service is how I think of it. What's the Google? So Paxos is the other algorithm. I forget what the Google distributed lock service, Chubby lock service. So I think it's like the Apache version of Chubby. And so that's going to help the cluster as a whole maintain a shared sense of state. Kind of like a clock, but not really going through the rigmarole of keeping everyone on the same like synchronized nanosecond time or anything like that. But that's going to help the cluster kind of see the same state. And in Kubernetes, that's handled by etcd, I think. And just so that we're kind of on the same page overview-wise, well, here's a diagram. That might be useful. I wanted a picture of a physical computer cluster. Sure. So this is some computer cluster. Each rack we're going to imagine has a computer. That might not be literally true. But these all have to talk to each other. And if you schedule a job, something has to make sure that if it's a computational job, something has to make sure that the right number of machines are computing the appropriate things. if it's like a web serving job, someone has to make sure that there's like redundant copies and enough redundant copies. And essentially the way that works in something like Borg or Kubernetes is there are a few master machines, which I'm going to imagine are at the top. And then there are a bunch of what you might call worker machines. And the master machines do master election with like a distributed log service, like in this case, probably Zookeeper. And they make decisions about what the other machines will do. And in Borg and Kubernetes, the machines run a little program called the Borglet or the Kubelet that talks to the master and receives work that it's supposed to do. I'm going to guess that Mesos does something more or less similar, although I'm not sure. We do have this this diagram. We do have a Mesos master, so that's good. We have a standby master. So these are basically, I'm going to guess, are there for redundancy, but this machine has won the master election. And these are called Mesos slaves. So they run different executors, which I'm going to guess is maybe like a generalized version of the kubelet. So there's a Hadoop executor and an MPI executor. MPI, I'm going to guess, is message passing interface. And then this one is running both executors. So it sounds like maybe, unless this is not showing everything, maybe instead of something like the kubelet, it has like the kubelet thing is kind of like an executor that has a what's the word? It's like an interface, and then multiple things can implement it. And then we have a Hadoop scheduler that the master talks to, and an MPI scheduler. And this is, I guess, because of this breaking down into different Hadoop versus MPI jobs. And this is supposed to be the Zookeeper quorum. So somehow, I don't know why these are circles and not machines, but somewhere there's a Zookeeper like cluster that has information about what the state of the world is and like who is master. So that's, I guess, if I'm reading that diagram correctly, that's kind of what's going on. I don't know if there's another more detailed diagram. This is literally the same one on a slide. Okay. So with that in mind, let's take a look at what? We have scheduler, appc. I kind of want to see master. I don't think I saw master. I did see slave. Oh, I do see master. All right, so let's open master. Okay, there's a lot here. Bot Eater is saying, thanks for the explanation. That enlightened me a lot. I didn't know about any of this. Oh, cool. Well, I'm glad that helped. Okay, so flags is going to be flags. Constants is going to be pretty boring. In fact, I'm going to make master its own thing. Authorization, header, and CPP file. Machine is probably going to be like the software model of a machine. Maintenance, who knows? Master is probably where you want to be. Master CPP and master.h. And there's some stuff about quotas. A registry. We do have protos. And a registrar. These might be registering like services. So in Kubernetes, you have like things like deployments and services and whatnot. And this might be doing something similar, like a service registry. So let's look at no, that's machine. Let's look at, where's master? All right, here's the master header. And we've got some indication of what's going on over here. We have a rate limiter. So that's going to do things like rate limit queries to the master and authorizer object approvers. So presumably object approvers is going to be something that, like, I guess you can implement that can approve whether something can be scheduled. In a machine this big, it's not like one person in his pajamas scheduling jobs, unless you're like Elon Musk and you have your own like data center for running your like personal uncensored AI or whatever people do if they have tons of money. But instead, this is going to be at some organization like a university, and you can imagine that each department has rules about what can be scheduled. If you're in the chemistry department, you can probably schedule compute intensive protein simulations so that the graduate students can get their work done, but you probably can't schedule Bitcoin miners. So there's going to be some logic that approves that. That might be something that Object Approvers does. It might not be, but that's the kind of conceptually what I'm thinking of it as. I don't know what the whitelist watcher is. That might be just like some facility for whitelisting certain kinds of things. And then we have master, registrar, slave, observer. It's a really unfortunate name. Slave and master. How many master classes do we have? Okay, this is just like a forward declaration sort of thing. Okay, so let's jump down to the whoa. How do I get rid of this? I liked where we were before. All symbols. Not everyone has this like stuff on GitHub. I guess you have to like enable it somehow. No, I want the second master. This one. Okay. So the master is going to extend proto-buff process of master. And it has a Mesos allocator for allocating something. I don't know if it's allocating memory or resources in general. It has a registrar. It has files. It has a master contender, a master detector. I don't know what those would be. An authorizer and a rate limiter. And a slave removal limiter. Flags. So those are, so authorizer is going to, I guess, be how the master authorizes things. Rate limiter is going to be how the master rate limits things, and so on. We're in the header, right? Okay. And these are message handlers. So in Google world, these would be like RPCs, but they're, I guess, just like function calls here. So you can submit a scheduler. That's kind of like a set operation setter. You can register a framework. You can re-register and unregister frameworks. You can launch tasks. You give it a from UPID. That might be the ID of the person or the machine requesting the tasks. And then you have a launch tasks message. And I'm guessing that's essentially a proto. How many protos do we have? Pro2. We have just a registry.proto. So I don't know. Can I click on this? No. What's the command to bring up VS Code? I love these names. Let's see. Is this it? I thought it was just like period or something. But maybe I was pressing the wrong thing. I don't know how long this is going to take. I guess that's fine. I'm not going to, I don't know if this is going to show account stuff. I don't want to do that. But let's do it in Emacs. Okay, where are we? So I wanted to look at the launch tasks. Okay. So the launch tasks message is just a message. We are in a proto file. I don't know where we are. Source messages. Okay, so we are using protobufs. And it just has a framework ID, some task info, repeated. These are, so these are, oh, no, never mind. This is required. So you have a bunch of task infos and you have some filters. I don't know how the filters are being used, and you've got an offer ID. And I don't know what an offer ID is. It's just a string. Oh, it's a unique ID assigned to an offer. I don't know if we're like offering resources or what, but so that's what launch tasks is. And these are all, I'm going to guess, protos. You can kill a task, schedule a scheduler message. I don't know if you're sending a message from the scheduler or if it's for the scheduler to send messages to you. You can reconcile tasks, and that'll do something. You can imagine the sorts of things that might require reconciliation. I don't know what it does in particular. You can update a slave, passing in an update slave message, and update unavailability. Mark unreachable. Marks the agent unreachable and returns whether the agent was marked unreachable. Okay, so I don't know if this agent is the same as a machine or if it's like a process running on a machine. Authenticate just takes a from and a to. No, sorry, a from and a PID. That would be interesting to look at how that's implemented. Maybe we'll do that in just a second. And so on. And then we have the protected methods like initialize, finalize, consume, etc. So all that's pretty straightforward. You can imagine most of that seems like it's an API that makes sense kind of from first principles you could design on paper. Let's look at the master, what was it? Authenticate? Subscribe. Let's see over here. Hang on, I need water. All right, let's just do Emacs. I think it'll be, here's Mesos proto. Okay, and I think I wanted to authenticate. Yeah, let's see if we can go here. What is this? I don't know. Oh, whoops. I killed my buffer instead of going to it. For whatever reason, I can't remember the key for find references, but I'll look it up in a bit. Okay. This is what I want, I think. Okay. So authenticate is going to, if due to network partition, there are two instances of the framework that think they're leaders and try to authenticate with master, they would be stepping on each other's toes. Yeah, currently it's tricky to detect this case because the authenticate message doesn't contain the framework ID from, doesn't contain the framework ID. From is the authentic key process with which to communicate, and PID is the framework slave process being authenticated. That's not at all obvious from the names of the arguments here. So PID is the person requesting authentication, and from is the process. I don't really know what that's saying. So the authentic key should be the one who's asking for authentication. So I guess this process is asking for authentication for this process or something like that. Or maybe they're asking if they can use this process. An authentication request is sent by a client, slave/framework, in the following cases. First time a client is connecting, this is straightforward. The client is retried because of zookeeper expiration. The client is restarted, etc. And then we'll try to erase the PID authenticated in some whatever authenticated like container. And if authenticator is none, and we do some stuff. And if the authenticating, I don't know where authenticating came from. If a new authentication is occurring for a client that already has an authentication in progress, we discard the old one, since the client is no longer interested in it. Okay, so this, I guess authenticating is some container that contains things in the process of being authenticated. And then we're going to start the authentication. We're going to call authenticator get and call authenticate from. That's going to give us some sort of future. And then we'll save the state into the container of authenticatings. And then when we get a future back, we'll try to, I guess, authenticate. And that's about it. And then here's the underscore authenticate method. I don't know where they actually do anything. Future is authenticated.put. Future is failed. So this is non-underscore authenticate here. And this is presumably going to do the thing that's authenticating. And maybe that's something that you can plug in or whatever. Silence my phone here. Shut up, phone. Okay, so I'm not going to dig into the authentication. I'm going to guess that's possibly pluggable. I don't even know really what the coolest stuff is. Here's the machine. The machine is simple. It's just a struct, a C++ wrapper for machine info that also stores some extra information. So we've got machine info and some hash set, which is like a set, like a Python set, I guess, if you do Python. It's the set of slaves currently registered from this machine. So the slave is not a machine. A machine has slaves. And somehow they're related. So I was watching a talk yesterday on Mesos, and one of the guys pronounced Kubernetes as Kuberentes, and also had the typo in his slide. And I thought that was kind of a cool name. I might start calling it Kubernetes. I'm wondering if there's like a dictionary here. It would be nice to know what concept corresponds to what. I'll say create a dictionary between Kubernetes concepts and Mesos concepts. E.g., what does a slave in Mesos map to in Kubernetes? Make a table. Let's see if DeepSeek can do that. Okay, this is pretty useful. So Mesos, a slave or agent, is a node or worker. So this is claiming that a node is that a slave is a machine. Although, I don't know. So a task is a pod. An executor is a kubelet, which we figured out from the diagram. Okay. So at any rate, so we have machine info and a bunch of slaves. That's all a machine is. Maintenance is probably not going to be so important. Maintenance registry operations will never report a failure while performing the operation. So we can update schedule. I don't know if this like stops everything like the way the garbage collection does. Start maintenance. Transitions a group of machines from draining mode to down mode. So there is some of this in Kubernetes as well. So you can drain a node and take it down, and everything, all of the other nodes will keep serving. And I'm assuming the same more or less happens here. And I'm just going to kind of move along because we don't have a lot of time, and this is a pretty big repo. Registry.proto is what? A top-level object that is managed by the registrar and persisted in a replicated log. So registry has a master and a slave. It wishes to store more information. What? Okay, messages and wrappers around existing objects. Okay, fine. So for extensibility, essentially. The slave info, so a slave is something that has slave info, And it also has information, I guess, about whether it's drained and whether it's deactivated. And then you can have some, you have multiple slaves because, like we saw in the picture, there's lots of machines. Most of them are going to be what are in this terminology called slaves. Although in more modern terminology, you might call workers or something. Okay, we have stuff about quota. That's all well and good. Here's the registry. What else? Okay, I think that's good enough for master. Let's take a look at examples. Do we care about examples? Test module util. No, let's keep examples around, but not look at it too much right now. So the scheduler might be interesting. We have constants, flags, and scheduling. That's about all there is. Unless there's more scheduling stuff somewhere else. And we have a good number of lines. 854 lines of code. We have a struct of connections, which includes what? Some subscribers and some non-subscribers. I don't know what that means. I guess like a subscription is a connection that's kept open, and maybe like a streaming connection in the RPC world versus a unary connection. I'm not sure if that's what's going on. We have a Mesos process, and it's got some master. I don't know if every process has a master, or maybe it's just a reference to the current master so you can reach them. And what do we have? We have some state, some Lambda functions for connected and disconnected. This might be like callbacks. Some queue, event queue, I guess, for receiving events from maybe from the master. Or no, this is a function. Yeah. It's just a Lambda function that's really a queue, I think, is what's going on. And optional, we have credentials and stuff like that. And I guess we need to verify the Google Protobuf version. And at the start, we initialize the process, initialize lib process. And then there's some logging. And if necessary, we launch a local cluster. I don't know what a local cluster is. Okay, so master can be local. This might be for like development, where you, in the Kubernetes world, maybe something like, I forget what it's called, like Minikube, something where you don't want to have like 7 machines to develop against Mesos. So maybe this is for imagining you have multiple machines and really you have just like a master process and some slave processes or something like that. Or like Docker containers or whatever. And what? We have disconnect, shutdown, and like sending messages. I don't know what devolve is. And so on. And we're setting request bodies. And this is kind of just, this all kind of makes sense. I don't know. This is like communication. I would like to know what we can find out about scheduling though. Callback, subscribe, process metrics for each. I'm going to guess that's about mapping over for all of the tasks at some level. Send, call, reconnect, stop. Event queue dispatches. So metrics this is going to be about presumably collecting statistics. I don't really see in here where we schedule something. Although I am looking at the CPP file, not the header. Is there like anything like fairness? Is there anything like round robin? How about robin? How about round? Let's look in the whole repo for fair. That's a scheduling thing, right? This is about resources. I don't know. Maybe we'll find some other stuff. Assume it's where we register the machines. I'm not sure. Let's look up let's just Mesos scheduler. I was thinking it was for, I mean, maybe you just request the jobs in some like JSON like format, and it will try to run everything. Subscribe. This is the first step in the communication process between the scheduler and the master. This is also to be considered as subscription to the /scheduler event stream. To subscribe with the master, it sends a HTTP post to subscribe. All right. The scheduler interacts with Mesos via the scheduler master endpoint. We refer to this endpoint as the suffix scheduler, blah, blah, blah. Accepts post data encoded as JSON. And what does it do? So I guess this is, yeah, maybe you're right. It's like scheduling a machine or scheduling sent by the scheduler when it wants to accept offers sent by the master. The accept request includes the type of operations, for example, launch task groups, etc., that the scheduler wants to perform on the offers. Note that until the scheduler replies to an offer, the offer's resources are considered allocated to the offer's role and to the framework. So maybe it kind of sounds like the master is saying like, I have these resources available. And the scheduler is saying like, I want these resources in response or something like that. That's how I'm going to assume it goes. And I'm going to kind of plow ahead. Here is slave. We have container logs. What are constants? Are these constants going to be useful at all? Duration. These are like default shutdown grace periods, etc. Okay. The garbage collection delay is 1 week, it looks like. Maybe that's for collecting a whole machine that has failed. Now, what does a slave have? We're not going to... Oh. We have this one. Struct. So it's not even a class. It's just a struct. The top level state. Oh, no, that's state. Did I? Yeah, I got confused. Oh, I looked at, no. I thought I was on slave.cpp. I got confused twice. Here we go. I'm guessing maybe the slave.hpp is in the include directory. Let's see if that's true. I don't know. I read it as slave to it. Yeah. I'm glad I'm not alone here. All right, so this looks more promising. Here's the slave thing. Okay. So we have a master detector, a containerizer. I don't know what a containerizer is. Some files, garbage collector, a task status update manager, some resource estimators. I'm going to guess for estimating your local resources, a quality of service controller, a secret generator, a volume grid manager. I'm guessing that's for like disks, persistent volume. Yeah, I'm going to guess that volume in the sense of disk and a grid in the sense of there's a bunch of them. A pending future tracker, I guess this is for keeping track of futures. And a CSI server. I don't know what CSI is. Container storage interface. Is that like the... Yeah, this is like the general thing, like a Docker server thing. Okay, so it's got some source of containers, and you can shut down. Here, this registered. Maybe that's for checking whether we have registered in the past. You can have re-registered. Do reliable registration. I guess this is like registration with some retry behavior that has a maximum back off. Handle run task message. So this might be for if the master tells you to run a task, it's going to have a UPID and the run task message itself. Let's take a look at run task message. This should be some proto. This message is sent when scheduler call accept is sent with offer operation launch. Okay, so run, still don't know what a framework is. Maybe we can figure this out. A framework is the same as a custom controller or operator or Kubernetes itself. Mesos frameworks, for example, Marathon and Kronos, are like Kubernetes controllers that manage workloads. Kubernetes itself handles scheduling natively. Okay, so this is some control object that works with Mesos. Okay, so it's got some controller thing. It's deprecated. And instead of a framework ID, we have framework info, which is probably an ID, but also other stuff. And we also have task info. So we're going to run a single task, I think. This is some resource thing used to establish the relationship between the operation and the resources that the operation is operating on. Okay, whatever that is. And a PID of the framework. I'm not really sure if the framework is running locally or on the master. And then a launch executor. If this field is absent, depending on task info, this message either notifies an existing executor to run the task or starts a new executor and runs the task. Starting at 1.5, this field will always be set. Agent should only launch an executor if this field value is true. It's a Boolean. Okay, so this is like whether to launch a new executor or reuse an existing one. I'm not sure how you know what your executors are, but they must be like registered somewhere, and there must be something that says like if it's a Hadoop job, use the Hadoop executor or use the other executor otherwise, etc. Let's take a look at the task info proto. GitHub is really slow at this. I don't know if it's just my computer or what. Okay, so task info describes the task passed from the scheduler all the way to an executor. Okay, so the scheduler, I think, runs on the master and communicates with the slave. And the slave is going to take this task info that comes from the scheduler, wherever it runs, and hands it to the executor, which is the thing that I think is ultimately going to run things on the machine. Either the executor info or command info should be set. Okay, so I guess the task knows about which executor it's supposed to use. A different executor can be used to launch this task, and subsequent tasks meant for the same executor can reuse the same executor info struct. Okay, so a task has a name, an ID, a slave ID, I guess where it's supposed to run. Resources, presumably resources that it needs, like does it need GPU or disk or whatever, and some executor info, which executor to use, I assume, and command info. I don't know if these are commands for the executor. And some stuff about containers. Task provided with a container will launch the container as part of the task paired with the task command info. So this is, I guess, enough information to construct what kind of container to create. And then we have a health check for the task and a something about checking info and a kill policy and some like arbitrary data you can send as bytes and labels. Labels are free-form key-value pairs which are exposed through slave and master endpoints. They will not be interpreted or acted upon by Mesos itself, and these are used for something. I don't know. Kubernetes also has labels. They can be useful in various times. And this is service discovery information and is not interpreted or acted upon by Mesos. It is up to a service discovery system to use this information as needed and to handle tasks with blah, blah, blah. Okay, so this is maybe for like add-ons is what it's saying. So or like things in the Mesos ecosystem, but that Mesos is making available, but is not using itself. Labels equals process metadata. Is it? Labels should be used to tag tasks with lightweight metadata. Labels should not contain duplicate key value pairs. I think in Kubernetes, at least, labels are used for all sorts of stuff. You can imagine using it for like red-black deployments. You might decide to, let's say you have like a web service with some experiments you're using for A/B testing. You might use the labels to indicate which, whether the button is blue or brown, and that will let you easily check things, I assume. And suppose you have like some monitoring, you might be able to look at the click-through rate based on tasks split by a label or something like that. I think that's maybe the sort of thing they're for, but I really don't know. I do want to dig into, though, the executor info. I'm becoming curious about these executors. We'll just do a search. It's in the Mesos proto. Kind of the nice thing about protos is like a lot of the action is in the protos. All right, so it describes the information about an executor, and it's an enum. So we have a limited number of types. Mesos provides the built-in default executor that frameworks can leverage to run shell commands and containers. Okay, so you can run something in Bash or whatever that's pretty freeform. That gives you enough to almost do anything, but it doesn't have a lot of structure. Command must not be set when using default executor. Default executor only accepts a single launch or launch group operation. So that's the default, and then we have custom. For frameworks that need custom functionality to run tasks, a custom executor can be used. And you have to set a command. So what does a custom executor look like? I don't know. So we have an ID, a framework ID, an optional command with command info, and some container stuff. I don't know what happens. So the last message we looked at also had container info. So maybe this is the container for the executor. Executor provided with the container will launch the container with the executor's command info. And we expect the container to act as a Mesos container. Okay, so this is like if you are using, I don't know, Hadoop, maybe. Then you might run Hadoop in a container. And then when Hadoop runs a Hadoop job or task or whatever, the task info also has a container. And so this container would maybe run the task container. And so that's why there are two separate containers for executor info and task info, I think. We have a source. It's an identifier string used by frameworks to track the source of the executor, etc. Okay. So let's just, out of curiosity, see if we can find a list of executors or executors. No. What? Google Lens. What did I do? Airflow, Apache Airflow seems to have an executor. This is just the API, right? I'll ask DeepSeek again. What are some famous Mesos executors? All right, you're going to take a while. Let me see if I can close more tabs while this is going on. All right, that's slave. That looks good. State, I think we can ignore. V1, I think we could probably ignore. I think we're going to wrap up in just a few minutes because I have to go. And in about 4 minutes. Web UI, this will be pretty useful, but it's going to be some JavaScript thingamajiggy that talks to the backend and makes it useful. And Zookeeper, we don't have a lot here. 581 lines of code. We have some like reference to the Zookeeper process, session timeout, et cetera, initialize. There are two different timeouts here. Session timeout is the client's proposed timeout, init loop timeout, et cetera. So I'm not really sure what we're doing, but we're like talking to Zookeeper. Finalize get state. And we're just getting a Zookeeper state and wrapping it in whatever a zoo state is. And then we have some authentication routines from credentials. And then we can create, giving it a path and some data and a vector of access control information, an ACL vector. And I guess we get back a result and an int, which might be like a success condition. So the way that Chubby works is there are, it has paths that contain information. And I assume that's what a path is here. So there's some namespace. Whoa. Can I see this, the non-alpha version? No. Okay. So you have, this is like the root, and then you have app 1 and app 2, because I guess you can use the same Zookeeper cluster for all of your stuff. And you have app 1, P1, P2, and P3. I don't know what P is, but these are like a small amount of information, I think. Kind of like maybe like the proc system in Linux, except in a distributed system. And these, I think the idea is that the information contained at these paths are just kind of like the bare amount of state you need to keep your distributed system operating. And we have zoo, create, etc. And I really have to go. So that's a little bit of Mesos. I don't know if it's worth digging in much further because it looks like it's not actively being developed. We'll take a look at the executors that DeepSeek has found out about. Mesos Containerizer, the built-in executor for running tasks, supports Docker, app-c, and native containers. The Docker one, I guess this is for maybe at the container level. And then the Universal Container Runtime Thermos, Twitter's custom one. Singularity by HubSpot. The Singularity scheduler for long-running services and scheduled jobs. Spark. So this is for running Spark tasks, Apache Spark. And Hadoop. And Myriad. So that's it. And Bot Eater is asking what's next to explore. The person who had requested Mesos had also requested Yarn, and had I think that's the next request with the most donations. And I got behind on requests, so I think I have to do maybe one or two more extra ones, plus the one at the end of this week. So I'm thinking that maybe Yarn is next, although something like that. I'm going to say Yarn is next, and then the next one I want to do that's not a request is Aider, the AI chat, open source chat vibe coding assistant thing. So I think that's what we'll do. And hopefully I will see you all then. Thanks for watching.